Good afternoon, everyone, and welcome to today's investor webinar for ABX Group Limited. I'm David Tasker, and it's a pleasure to be hosting today's session. With us is ABX Group's Managing Director and CEO, Mark Cooksey, who will be walking us through the exciting recent progress made at the company's Deep Leads Rare Earths project, particularly the delivery of a bulk sample to ANSTO for production of mixed rare earth carbonate, or MREC. This represents a major step forward in ABX's ambition to become a supplier of high-quality rare earths, with a strong focus on those all-important magnetic elements like neodymium. Oh, I'm not even going to pronounce them. There's a whole of really good ones in there, and Mark is actually going to be the one to explain them all for you. After Mark's presentation, we'll move into a short Q&A. Please feel free to submit your questions via the chat box. Mark, without further ado, I'd like to now introduce you and give you a chance to pronounce some of those hard pronunciations. Mark, over to you.
Great. Thanks, David. Got to do some more coaching with you. That's okay. So welcome, everyone. And so today we're going to explain more about the announcement we made yesterday about the sample, the bulk sample we've delivered to ANSTO for them to produce a mixed rare earth carbonate product. Next slide, please. So firstly, what have we done? So this map here, it's a section of our resource in northern Tasmania. You can see all the red dots, all our exploration drill holes, or a large number of them. This represents the core part of our resource. And then a few months ago, we dug three what we call trial pits. And so a picture on the top right shows one of those pits being dug and then it being rehabilitated below that. And from each of those, we took several hundred kilograms of material. And so there's twofold purpose. One is to get a real understanding of what the geology looks like. You can see much more when you take out several hundred kilos than when you do a small exploration drill hole. And then the second reason was in order to produce samples, which we're talking about here. So next slide. So one thing that's often not well understood with these, with rare earths, is on the left, we have the ore, and then we process it to get the rare earths out. And for an ionic clay, this particular type of ore, the processing should just be leaching and precipitation. And from that, we produce what's called a mixed rare earth carbonate, or MREC. And a mixed rare earth carbonate is all of the rare earths are still mixed together. There's like 15 of them in various proportions, but they're relatively pure. The amount of impurities of other elements like aluminium and calcium should be very low. And so what is important for the economics of this sort of process is on the left with the ore, you want size and grade. So a bigger deposit is good for economies of scale and mine life, but grade is really important for cost. If the grade is higher, there's less dirt to move. For the leaching and precipitation, what's really important is what's called the extraction, which means the proportion of the elements, the rare earth elements that are recovered. So, for example, you may have a very high grade, but if your extraction is very low, or in some cases zero, you've got nothing. None of it goes through to the MREC. And I highlight there the four magnet rare earths. So NdPr are the two light rare earths, neodymium and praseodymium. And Dy and Tb are the two heavy rare earths, which are even higher value, dysprosium and terbium. So those first two things, the ore and the leaching precipitation, lead to production costs. They have implications for production cost. And then finally you get your product, and those factors there, how much of those magnetic rare earths you have dictate the value of the product. So all these three things are important. And I really encourage people, when you're reading announcements by us or by peers, really look at whether people have reported all of this information, because it's all important. Okay, next slide. So ABX has done all its metallurgical testing to date with ANSTO. So ANSTO, the Australian Nuclear and Science Technology Organisation, are the Australian experts in rare earths, because many rare earth deposits are radioactive. ANSTO was well set up to do that work. So for 30 years, they've been the leaders. And so most companies in Australia and some overseas ones send samples to ANSTO for metallurgical testing. So the advantages of them, high quality, very, very good people, very reliable results. They can do all the process steps, so they can do the leaching, they can do precipitation, and they can even do solvent extraction, which is then separating the MREC into all the individual rare earths, and they're internationally recognized. So we use them, and others do, when you're testing something new for the first time, or you're wanting to provide results for customers or the market. They're very credible and recognized. But what we've done in ABX, we've also set up our own in-house facilities, effectively duplicating some of what ANSTO does. And we've done this in Launceston, so our technical team's done this. And the features of our testing is still pretty good quality, maybe not quite at ANSTO level, but still perfectly acceptable for most purposes. At the moment, we can only do leaching, but we're thinking of doing precipitation as well. And the real key thing is short turnaround. So we can test, samples that we've collected from exploration drilling. We can test them straight away. If we have an idea to test something slightly different, we can do it straight away. Whereas if you've got to send everything to ANSTO, you've got to negotiate a scope and a price and send the sample and wait for the results, and it's slower. So these are complementary. So we're using our facilities for routine testing and, as I said, rapid investigation of parameters. And we think it's a bit of a differentiator for us. As far as we know, we're the only company in Australia doing our own in-house testing of this type. In fact, we don't know of any in the world, but probably wouldn't quite make that claim because I'm not quite sure. Okay, next slide. And so what is this, our in-house capability has allowed us to do in this case is actually pre-test the samples before sending them to ANSTO. So normally what any other company would have to do is, we've dug up a sample, we want to get ANSTO to make an MREC, we'll send the sample to them and we hope it goes well. What we can do is do pre-testing. So with these samples, we got the grade measured. That's fine. Everyone can do that. But then we've actually done the leaching tests. So the critical things here I've highlighted in that lime green is, firstly, in the sample itself, there's that terbium and dysprosium, that 0.7% and 4.3% in the middle of the screen. You might think, oh, so what? They are very high numbers. So a lot of deposits, maybe only 0.2 of the percent of the rare earths would be terbium, and maybe 1.5% of the rare earths would be dysprosium. So our numbers are high. And that's important because the prices of those two rare earths are particularly high. So as a rough guide, if you take an MREC, most of the rare earths are basically worth almost nothing. The NdPr and the DyTb are worth something. In our deposit, the NdPr is worth about half of it, and the TbDy is worth about half. So even though that percentage is lower than the Nd and the Pr, the value is very high. We then did the leaching tests ourselves, multiple tests, and you can see those proportions basically flow through to the leach solution. And the other critical factor is the last column on the right, that extraction. So between 60 and 69% for each of the rare earths. That is a very high number for the conditions we use. And we use these standard ionic clay conditions. They're written across the bottom. The key one is pH 4. You might say, what the hell does pH 4 mean? It basically means just salt water. So that's a very low cost extraction. It also means that you don't extract the other impurities like aluminium and calcium. And our numbers are as high as anybody else in the world on those. Most clay hosted samples, when you do that test under those conditions, you get zero extraction, or maybe 10%. So again, I encourage you, when you're looking at announcements from various companies, really look at when they report a recovery or an extraction, look at what conditions they used and what part of the process they're describing, because what really matters is your overall extraction from the ore all the way to the MREC. There's lots of steps along the way, so believe me, it's complicated for our team to understand it, let alone for investors. So yeah, we think our game changer or distinguishing features for us, really high proportion of dysprosium and terbium, and very high extractions under those conditions. Okay, next slide. So next steps, well, ANSTO's got the sample. They're starting preparation shortly, so we expect they'll convert that 100 kilograms of bulk sample into a small MREC sample during the fourth quarter. We've been talking to customers for 2 or 3 years, prospective customers. We've announced stuff with Ucore. You probably saw that last year, an MOU with them. Customers like Ucore and others are now really keen to see what our MREC can look like. So up to now, it's been, yep, we can see your resource. That looks pretty good. You've got great metallurgical results. That's really exciting. And we've been able to engage with them. But to take it to the next level, they're saying, well, look, we'd like to see samples. And so that's what we're doing. So we hope to get a real positive response from prospective customers later in the year. So thanks very much. Happy to answer any questions.
Thanks, Mark. Great presentation. We do have quite a few questions that have come through so we'll jump straight to them. This is obviously a key milestone for ABX. Can you walk us through what makes this delivery to ANSTO so significant for your rare earth strategy?
Yeah, so as I said, it's up to now, we've been able to say our resource has good grade, particularly of the dysprosium and terbium. That should mean that an MREC is good quality, and our good extraction results in metallurgical testing should mean that when the MREC is produced, that recovery is achieved in that situation as well. This is actually a test to confirm those, pretty solid expectations, but this will actually confirm it, and really with customers as well, confirm it. It's one thing to say this should happen, that should happen, but to actually have evidence of it is more powerful.
And you've highlighted ABX as the only company in Australia conducting in-house tests on clay-hosted rare earths. How important is this in building credibility with future customers?
Yeah, it's a good question. I'd partly thought of that. I mean, one is just internally useful, as I said, because we can do tests quicker and basically quicker. But yes, I think it does. We definitely have a reputation. The customers have said to me, "Hey, Mark, we're impressed with your technical team. You guys, sound like you know what you're doing." And again, this is evidence of it. If we will obviously, when this MREC is produced by ANSTO, we'll announce those results and compare them to the results that we got in-house that we've announced yesterday. I expect them to be very close, which again will, I think, build our technical reputation with customers.
And the leaching extraction rates from your latest test work look very promising, particularly for high-grade and high-value magnetic rare earths. How do these compare to what's been seen globally in similar ionic clay deposits?
Yeah, so we get, the highest results you see for like the odd sample, in the 80s, or maybe, so the odd sample's 90%, but basically if you get 60 or 70%, for across the board, in this case it's a large sample, that's very good. And I guess the bigger point is that most clay, our assessment of it, looking at lots of data from lots of different deposits, is for most deposits under those conditions, you actually get 0 or maybe 10%. So there's it's not so much that, how close is 70 to 100, it's that 70 is so much better than 10 or 0. And so if you've got a deposit where you get very low, less than 10%, clearly that's, not viable unless you had it some amazingly high grade. What you have to do is use different conditions. And basically that means more acid, which has two things. One, more cost, but more importantly, more impurities into the product, and a more challenging rehabilitation, because you've got to neutralize that material before you return it back to the surface. So I really encourage people to look at, most clay-hosted deposits under those conditions get very low extraction.
Now, this is a bit of a leading question, so I'll remind you and also the viewers that we're not in a position or have any desire to break continuous disclosure obligations. But let's talk about the commercial angle. How's the market reacting to your plans to produce a mixed rare earth carbonate? Are you already engaging with potential offtake partners? Is the phone starting to call? Phone starting to ring?
Well, I think that the phone was ringing beforehand. So as I said, we have got an MOU with Ucore. We're talking to a number of other um, prospective Western customers for our MREC product. I was on a call with one of them just a couple of weeks ago where they didn't even know about this plan to produce an MREC, and they said, "Hey, Mark, this is really interesting. Actually, what would really get our team excited is an MREC sample." And I said, "Well, coincidentally, we've just in the process of sending one off to ANSTO," and they're like, "Great." So um, I think for the people we talk to, this is a logical step. What will definitely get them actually excited is the results.
And just sort of extrapolating that a little bit further, what will success at the ANSTO stage enable you to do next? Can you outline the path to commercial scale production and what milestones investors should look at from the company over the next 6 to 12 months?
So I think the key one is feasibility studies, or starting with a scoping study. So we've already got a resource. It's pretty good in size and grade. I mean, we're still looking to grow it. But actually, the rare earth market is not that large. So where the real opportunity is to get a profitable operation into production relatively quickly. And so our engagement with both customers or prospective customers and engineering companies is about what are the options for a sort of two-stage project. There's the ultimate large project, which maximum possible return, largest project life. But what is the interim stage to get there, which very feasibly could involve smaller scale production to start with, but profitable. And how can we take advantage of our location being, 50 k's west of Launceston, the infrastructure's there, etc. Can we be profitable quickly to satisfy these prospective Western separation plants that really are starting to worry that they will not be able to get MREC, especially MREC with high dysprosium and terbium.
So, question here, I'm not sure if it's a technical or not, but uh, what would the weight of the MREC be out of a 100 kilogram sample?
Yeah, that's a good question. So, roughly speaking, these ionic clays are roughly 1,000 ppm, which means 1,000 parts per million, which means 0.1%, which means if you have a ton of ore, you've got 1 kilogram of rare earths. So in this 100 kilograms of sample, 1,000th of that is 100 grams. So that's a good indicator of this commodity. It's only 0.1% of the material is rare earth, but they're very high value. I heard a number the other day of terbium being over $1,000 per kilogram. So very high value.
Question here in relation to impurities. The low cerium extraction is interesting, but what does the impurity numbers look like?
So that's another reason why we're producing the MREC, because the answer is you don't know. So, well, more to the point, if we reported the leaching results, we know how much aluminium and impurities have come through to the leaching solution, but that's not that meaningful. What matters more is how much of that then goes to the next step into the MREC, and that's the reason, or one of the values of getting ANSTO to produce the MREC, because we know the rare earths will come through, but the question is how much of the impurities come through. We expect ours to be good because we've been able to do this leaching under these conditions, but we don't actually know for sure until the MREC's produced. I appreciate the people that have dialed in today. Interested to hear more. I know it's can be a little bit technical, but they're important factors for rare earth production. People, you can go to our investor hub to put in further questions, and I'm always happy to take a call. Right, just my number's everywhere. So if you've got a question, you go, I didn't understand that, please give me a call or send me an email. Happy to answer them.